Okay, so just like in the previous videos, after I do each problem, I would strongly recommend that you take a second and see if you can complete the other parts of the problem, since every single problem in here has multiple parts. So I want to do part A, see if you can do part B and C before watching and finding out the answers. Okay, so period and amplitude. Okay, in order to figure out what the period is, so I'll put a little note over here to the side. The period is always just 2 pi divided by b. The amplitude is always your a value. And I'm using b and a here, so you might be asking yourself, well, where's b? A and b. A and b are part of this equation. So I have an order. You see I have 4 different values. I have A, B, and C, and D. So in this problem we're only talking about A and B, but anyways, I just figured I'd remind you where all those values are coming from for later on. For part A, it says -4 sine of 3x. So the period, how long until it repeats, is just 2 pi divided by 3. And that's it. We can't do any simplifying with that. So that's our final answer for the period. Now the amplitude is +4. So yeah, it's just the a value up front, but I want to stress here that it's the absolute value of that number out front. Okay, so remember, amplitude is like the size of the function. Like basically, if you're looking at it on a graph, how tall the graph is. Okay, so that's kind of like an easy way to describe it. Not really the mathematical way to describe it, but anyways, we're just looking at the size of something. So it's just a positive value, +4. Amplitude is always positive. Okay. All right, the period for part B. Again, before you watch me do this answer, see if you can pause and then get it on your own. 2 pi divided by 8, which simplifies to pi-4ths. The amplitude, well, think about it, there's really like a 1 out here, so our amplitude is 1. That doesn't change anything by putting a 1 out there. And our period for part C, 2 pi divided by 1/3, which if we multiply by the reciprocal of 1/3, that's here in the bottom, reciprocal of 1/3 is 3, so we're really just multiplying 2 pi by 3, and we get a final answer of 6 pi. Amplitude, did you put -1/2? Be careful. Remember, amplitude is always +1/2. I'm sorry, it's always positive. In this case, it's +1/2. Okay, so these go back to your trig identities, and we're just asked to figure out which ones of these expressions are equal to 1. So you see a bunch of different expressions here, and only a few are actually equal to 1. So I'll go through 1 or 2 with you, and then again try to pause and see if you can do it on your own. So remember, a little trick for simplifying trig expressions or trig identities is to write everything in terms of sine and cosine. So I'm going to use that little trick here in the first problem. I'm going to write sine squared of x plus cotangent squared of x. Well, cotangent is cosine over sine. Don't forget to include those squares. That's important in a lot of the problems. And you'll notice that this fraction here, it's going to cancel out with this here. So the sign in the denominator here is going to cancel out or divide out with the sign on the outside here. So what we have left over after we do that simplification, we have sine square root of x plus cosine square root of x. Well, if you take a look at your identity sheet, sine squared plus cosine squared is equal to 1. So this is definitely one of the ones that is equal to 1. So if we move on to part B, I'm going to try that same trick by writing everything in terms of sine and cosine and see what happens here. I'm going to write 1 over the cosine squared, because that's what secant squared is, plus tangent squared, which is sine over cosine. And if I do a little trick here, get a common denominator, I know it looks a little complicated with cosine and sine, but it's still the same concept as what you learned in middle school with adding and subtracting fractions. We're going to take the what am I doing here? I'm thinking ahead. We don't need to we already have a common denominator. I'm thinking on the left hand side this is sine. I'm sorry, we already have a common denominator. Okay, moving on. We get 1 plus sine squared of x over the cosine squared of x and there's really no way we can simplify this any further that we're going to get 1. I do want to point out though that, again, this one is not equal to 1. I want to point out that if this was a minus sign on top, which is not, but if it was 1 minus sine squared of x over cosine squared of x, we could manipulate the top 1 minus sine squared of x off one of the Pythagorean identities, and this does equal cosine squared of x divided by cosine squared of x, and that does equal 1. However, again, this is not a minus sign, it's a plus sign, so we can't do that. So we are done. Part B is not equal to 1. Okay. So if you just quickly want to check yourself, the next couple answers, I'll let you know which ones are equal to 1, but then I'll go through and show the work. Part C is equal to 1. Part D is equal to 1. And so is part G. Okay, so I'll go through and do the work for each one of those so we understand what's going on. So I apologize, I didn't leave you guys a whole lot of room. I'm going to go into a clean sheet of paper so I have plenty of room to do each of these. Okay, so now I have plenty of room. So let's try it on here now. Okay, so part C I did say was equal to 1. So sine squared of x over 1 minus cosine of x minus, we need a common denominator for this so I can put these fractions together or put these terms together. Okay, so in order to get a common denominator, remember that this is just really cosine of x over 1. So I want to multiply the top and the bottom by what I see on the other side there. 1 minus cosine of x. Whatever I do the top, I have to do the bottom. When I do that, to get my common denominator, what I get is cosine of x minus cosine squared of x all over 1 minus cosine of x. Now I can put these two fractions together because they have the same denominator. So I'm going to write sine squared of x. I'm going to reorder this and you'll see why in 1 second. Minus cosine squared of x minus cosine. Again, I reordered it. You'll see why in just 1 second. Right here, you might notice that this looks pretty similar to one of the Pythagorean identities. That's just equal to 1. Minus the cosine of x over 1 minus cosine of x. So we have something being divided by itself, and we all know that that's equal to 1, so it checks. Okay, so my plan for attack in part D is going to be that little trick again by trying to write everything in terms of sine and cosine. I believe on your packet you should have a multiplication symbol here. Okay, so again I'm going to write everything in terms of sine and cosine first, and then I should see some things cancel out, which is again the trick that we're going to use. So cotangent squared is cosine squared of x over sine squared of x times the sine squared of x, all divided by cosine squared of x. Oh, that's nice, because now the sines cancel, and we're left with cosine squared of x all over the cosine squared of x. Anything divided by itself is equal to 1. That checks as well. So let me show you the last part that is equal to 1. I'm not going to show the other ones, but no matter what you do manipulating, they will not equal 1. So I'm going to go back at the problem. I said that part G was also equal to 1. The other ones again are not. I'm not going to show the work for them. I mean, no matter what you do to them, they're not going to equal 1. So we'll just kind of leave it at that for now. Okay, so let's take a stab at this one. Again, I'm going to write everything in terms of sine and cosine. It's going to be my plan of attack. It's usually worked really well. 1 over the secant squared is just simply cosine squared of x. 1 divided by the cosecant is just sine squared of x. And that's one of the well-known Pythagorean identities. That's equal to 1. So that also checks.